Okay, class. There we go. All right, let's go ahead and dive into the next big step in the history of the atomic model. But before we do, I want to review really quickly what we learned about J.J. Thomson, since that was all the way back Friday. Remember, he discovered electrons. Those are the tiny negatively charged particles. And he came up with the plum pudding model. He thought the atom was a big positive blob, like the cake of the plum pudding would be this positively charged matter, and then the electrons were scattered throughout, kind of like raisins in that plum pudding. Okay, so now look at the image on this slide. So this is from Rutherford's famous gold foil experiment. You know what? Hang on one second. I wanted to point something out. Look at the dates. So Thomson came up with his atomic model, the plum pudding model, in 1904. And just a few years later, Rutherford was running this gold foil experiment, and then he came up with his alteration to the atomic model. So again, you guys, when we think about Democritus at 400 BC, and then 100 years, 2,000 years, and then it was 100 years between models, and now it's just a handful of years. And so because the technology, the experiments, things were happening so quickly during this time. Okay, so Rutherford's famous gold foil experiment. So he was testing Thomson's plum pudding idea. It's important for you to understand and to know, and you probably already know this, but I wanted to remind you, it's not like one scientist can say, hey, everybody, this is the way it is. And everybody goes, oh, yeah, you're right. Good job. Everybody says, oh, cool. Okay, let's test it and make sure you're right. So that's what Rutherford was doing. And he shot tiny particles. These are called alpha particles. They're called alpha particles because they're positively charged. So he was shooting alpha particles at a super thin piece of gold foil. So if Thomson's model was right, Rutherford expected that all the particles were going to pass straight through that gold foil, and then he would see this kind of bright beam of light around this fluorescent screen. So everything would go straight through, because the positive blob would be spread out evenly. But something really surprising happened, and you can kind of take a guess based on this picture. So most of the alpha particles did pass through. So if you look, that alpha particle beam is going straight, and then you can kind of see that there's some that are going straight through, although you can see that they're kind of angled, right? So although most of the alpha particles did pass through, a few bounced back, almost as if they hit something solid. So this led Rutherford to an amazing discovery, the nucleus. He realized that the atom had a small, dense, positively charged center where most of its mass is located. And he also discovered protons, which are the positively charged particles inside the nucleus. Now, I want to take you to a link. This is a link from the University of Colorado. It's PHET Interactive Simulations. They have all kinds of simulations, really, really cool computer simulations. And I found one on Rutherford scattering. And so let me take you through this. And I do have a link in today's folder in Schoology. So you can come in and kind of mess around with this on your own. But I just want to show you real quick a couple features of this computer simulation. So when you first open it up, you're going to see that you've got the Rutherford atom and the plum pudding atom. I want you to click on the plum pudding atom first, and you're going to see this kind of positively charged blob. I don't want you to mess around with this alpha particle slide where you could increase or decrease the energy. The way that it's set up right now is what Rutherford would have, like the amount of energy that Rutherford would have shot through. And on the left-hand side, you've got this little button here to turn on your alpha particles, and then you have the gold foil. So when you turn on the gold foils, this is what Rutherford was expecting to happen. So you can see from the key that those little things going through that positive blob, those are the alpha particles. And Rutherford, if Thomson was correct, Rutherford reasoned that what he would have seen is that all of these alpha particles would have just gone directly through, but that's not what happened at all. So we're going to go back, actually just down to the bottom, and we're going to click on Rutherford's atom. And so here's what actually happened. And again, all of this over here, the alpha particle and the atoms and the neutrons and all that, don't mess around with that, because that's what Rutherford would have seen. You can mess around with it after you've seen what I want you to see, but you'll turn on the alpha particles and look what happens. So we see these alpha particle trace. Let's see, how do I turn that on? Oh, I'm going to click right here. Yes, this is so interesting. Do you see what's happening? So Rutherford saw this going on. And he's like, wait a second. How comes, do you see some of those being bounced back? Or they're being kind of kicked off to the side? And what's happening is we have to remember what you saw with your magnets, right? Hang on one second. I got to find in my notes. I've lost my place in my notes. Okay. So what you will remember, and I probably have this written a little bit later on in my notes, but I'll go ahead and say it now. What you remember from our magnet activity is that opposite charges attract and like charges repel. So if this is what Rutherford was seeing, do you see how like they don't want to go, that those positive alpha particles want nothing to do with the center of these atoms? And so this is what led Rutherford to understand that there had to be something positive in the center of an atom, and that most of the atom's mass is here. And if we see these repelling alpha beams, then it had to have been positive. Okay, you guys can mess around with that later on. I want to come back here and show you this. So here, let's talk about your notes, okay? So I want you to write down that Rutherford discovered the protons and he identified the nucleus. Now, as far as the electrons, he didn't really know exactly where they were or what they were doing. And so he kind of just said that the electrons were just sort of there. But later on, this idea was corrected by other experiments, and specifically the very next scientist, Niels Bohr, he's going to correct this. So at the top, I want you to go ahead and draw Rutherford's atomic model. You'll see that dashed circle around the atom kind of represents the boundary of the atom. He's got inside the atom is a circle that's going to be larger because it's where the most mass is. It's where all the most of the matter that makes up an atom, that's where that's located. And that's positively charged. And then he's got the electrons just sort of scattered around. This one is actually a really good model because do you see how the atoms are not equally spaced around? That's because Rutherford didn't know what the electrons were doing. He just said they were just kind of around. We don't know what they're doing or if they have any sort of a pattern that they follow or anything. He didn't know that quite yet. Now, obviously, that part of his atomic model wasn't quite right. And later on, scientists figured out a more accurate model. But this will help you picture what he thought the atom looked like. Okay, let's move on from Rutherford to another important scientist, Niels Bohr, who took Rutherford's idea and he made them even better. Now, take a look at this. This is 1911. Only 2 years will have passed between Rutherford and Niels Bohr. Niels Bohr came up with this planetary model in 1913. Now, remember, Rutherford had no idea what was going on with the electrons. On this slide, you're going to see that there's a GIF of Bohr's planetary model on the atom, and it was important that I showed you this moving picture because that's kind of key for Bohr's planetary model. And I will have you guys watch the next slide or the next video to learn more about Bohr.